Hi children, this is the sixth video of the topic differentiation. Today we are going to discuss about nature of the turning points part 2. To watch more educational videos, please subscribe my channel and please click on the bell icon. When we discuss about turning points, we can observe three types of turning points. The turning point occurs at a minimum as shown in the first graph. A turning point occurs at a maximum shown in the second graph, and turning point occurs at a point of inflection that is shown in the third graph. Whatever the turning point, we can see one common property is that the first differentiation would be 0 at the turning point, whether it's a minimum, maximum or a point of inflection. How does this first differentiation answer become 0 at the turning point? You can see whatever the turning point, the gradient or the slope of the curve at the turning point is 0. From the previous videos we know that the gradient is explained by the first differentiation. Therefore, the first differentiation must be 0 at the turning point. What kind of questions they can ask you from this first differentiation and the nature of the turning point? The first question what they ask is, given that y equals to x squared plus 2x minus 12, find the x value of the coordinate of the turning point, and next part is coordinate of the turning point. In the first part of the question, they are referred to find the x coordinate of the turning point. Anyway, we know that from previous theory, the turning point is the point with dy by dx, or the first differentiation is 0. Therefore, as the initial steps, shall we calculate or shall we find the first differentiation answer, or dy by dx, for y equals to x squared plus 2x minus 12. If you differentiate y equals to x squared plus 2x minus 12, you receive the answer 2x plus 2. If you are still unable to calculate dy by dx, refer to my first videos. Now we have already calculated the first differentiation. Therefore, we know at turning point dy by dx is equals to 0. That means first differentiation answer 2x plus 2 must be equals to 0. If you simplify this answer, you receive the answer for the first part of the question, x equals to minus 1. Next part of the question, they want to find out the entire coordinate. We know that x coordinate is minus 1. Then what we are supposed to do is we need to find the y coordinate as well to write it as a complete coordinate. Then substitute minus 1 into the equation y equals to x squared plus 2x minus 12 to obtain the y answer. If you simplify this, you receive the answer as the coordinate of the turning point is minus 1 minus 13. Hope you have understood this theory. Let's move up to question number 2. The question is to find the x coordinate of the turning point and coordinate of the turning point for y equals to x cubed minus 2x squared minus 7x plus 1. Then the first part is we need to differentiate it. If you differentiate y equals to x cubed minus 2x squared minus 7x, you will obtain the answer 3x squared minus 4x minus 7. Then at the turning point, the first differentiation, or dy by dx, is equals to 0. We know that answer obtained for dy by dx is 3x squared minus 4x minus 7. Other than that, its a factorized form is 3x minus 7 into x plus 1. Therefore, you can write 3x minus 7 into x plus 1 is equals to 0. You will obtain the x coordinates as minus 1 and 7 over 3. Then we know that for this graph, you will obtain two turning points. One turning point at x equals to minus 1 and other turning point at x equals to 7 over 3. To find the y coordinates, let's substitute x equals to minus 1 and x equals to 7 over 3 into the main equation, y equals to x cubed minus 2x squared minus 7x plus 1. Then if you substitute minus 1, you will obtain the y answer as minus 13. Therefore, one turning point occurs at minus 1, minus 13. When you work out this question, children, most of the students do one common mistake. After obtaining the x equals to minus 1, to find the entire coordinate, they substitute this x equals to minus 1 into first differentiation answer. If you substitute x equals to minus 1 into the first differentiation answer, you will obtain the gradient as 0, not the y coordinate. Therefore, make sure to obtain the y coordinate, you have to substitute into the y equation, not into dy by dx equation. Hopefully, you understood this. To obtain the second coordinate of the turning point, you can substitute the x coordinate of the second point, x equals to 7 over 3 into the main equation. Therefore, you will obtain the answer minus 365 over 27. Therefore, the final coordinate or the second coordinate of the turning point would be 7 over 3 comma minus 365 over 27. Our next theory is to learn about the second differentiation. Up to this extent, we have learned how to obtain the first differentiation. For the main equation, if you apply dy by dx, you will receive the first differentiation. To obtain the second differentiation, what we need to do is, we need to differentiate the first differentiation again. That is called the second differentiation. For example, if you get y equals to x cube minus 2x squared minus 7x plus 1, then if you differentiate it once, you will obtain the answer 3x squared minus 4x minus 7. You have to use the usual differentiation rules. To obtain the second differentiation, you need to differentiate that answer. That means you have to differentiate 3x squared minus 4x minus 7, and you have to use the usual differentiation formula. In that case, you will obtain the answer 6x minus 4. That means if you differentiate 3x squared, answer is 6x. Minus 4x differentiation is minus 4. Minus 7, just a constant differentiation, is 0. Therefore, the final answer turn up into 6x minus 4. Up to now, we have learned how to find the coordinate of the first differentiation. Then from the initial slides, I have explained that wherever the turning point occurs, whether it's a maximum or a minimum or point of inflection, whatever the point, the first differentiation answer is 0. From our first differentiation answer, we can obtain the coordinate of the turning point only. From the first differentiation, we cannot discuss anything about the nature of the turning point. Nature of the turning point means whether it's a maximum or a minimum or point of inflection. To obtain the nature of the turning point, we use following proceeding. Initially, you differentiate the equation and equate into 0 and obtain the x coordinates of the turning point. Then after that, differentiate that answer again. That means you have to obtain your second differentiation. Into this second differentiation, if you substitute the x coordinate what you obtain from the turning points of using the first differentiation. If you substitute those figures, if you obtain a positive answer, just like plus 2 plus 3 like positive answer, that means at that point the curve obtain a minimum point. When you substitute that value into the second differentiation, if you get a positive answer, that means it has a minimum value. Then if you substitute that x coordinate into the equation, if you get a negative answer, means that is a maximum point. Remember that this is kind of little bit different than our certain theories we are learning in our previous topics. If the second differentiation value is positive, remember that it's a minimum. If the second differentiation answer is negative, means that is a maximum point. You have to understand this clearly. Let's try to apply our known theories to find the nature of the turning point for the curve y equals to x squared plus 2x minus 12. Remember children, this question is a continuation of question number 1. From the question number 1, for the same equation we already found, the x-coordinate of the turning point is minus 1. Using the first, if you differentiate this equation once, you will obtain 2x plus 2. If you equate into 0, you get the answer as x equals to minus 1. That is already done in question number 1. To find the nature of the turning point, what is supposed to do is I will differentiate that answer again. That means you have to differentiate the first differentiation answer 2x plus 2 again. You will obtain the answer 2. That means 2 is a positive answer. If you get a positive answer, what is the nature? Therefore, we can understand that at x equals to 1, x equals to minus 1, the nature of the turning point is a minimum value. That means at x equals to minus 1, you can see a minimum point for the curve. In this example, we need to find the nature of the point for the curve of y equals to x cubed minus 2x squared minus 7x plus 1. This is a continuation of question number 2. Therefore, we already knew from that question the turning point occurs at the coordinates x equals to minus 1 and x equals to 7 over 3. Then we will go ahead with the second differentiation, because to discuss about the nature of the turning point we need the second differentiation. If you differentiate the first differentiation answer 3x squared minus 4x minus 7, you will obtain 6x minus 4 as a second differentiation. Now, not like the previous question, the second differentiation answer is involved with the x coordinate. Then if you want to find the nature of the turning point at x equals to minus 1, the first turning point, what we need to do is substitute x equals to minus 1 into the second differentiation, means 6x minus 4. If you substitute minus 1 into that equation, you will obtain minus 10. Minus 10 is a negative answer. From our theory, we know if the second differentiation has a negative value, it's a maximum point. Then we will move up to the next turning point. The second turning point occurs at x equals to 7 over 3. If you substitute 7 over 3 into the equation, second differentiation answer 6x minus 4, you will obtain plus 10. That means when you get a plus value means the turning point is a minimum point. Now I hope you can understand how to identify the nature of the turning point from these two examples. Hope you have obtained a better knowledge about nature of the turning point, and if you like this video, put a big thumbs up, and to see more educational videos about mathematics, please subscribe my channel and click on the bell icon. Thank you and see you from more videos.